Hey guys, so today what we're going to be looking at is graphing simultaneous linear equations. We've actually done a whole bunch of stuff with simultaneous equations. We've solved things using substitution and we've solved things using elimination, and my phone just went off. And also we had a brief look at solving things graphically last term, but this term I really want to jump into it because this term is all about the graphing and I need to turn my phone on silent. Excuse me. Okay, so, excuse me. Today what we're doing, we are solving simultaneous equations using algebraic and graphical techniques, including the use of digital technology. So if you have a graphics calculator at home and you want to punch some numbers into there, go ahead and be my guest. Because really all we're doing is just going to be graphing some stuff and then just picking the point of intersection. So what I want you to do is I want you to go into your vocabulary and I want you to define the term simultaneous and I want you to define the term system of equations. All right, so let's start off. So a system of equations occurs when two or more lines are plotted on the same Cartesian graph. You could also be given a list of equations and that would be your system of equations. So to solve a system of simultaneous equations, you have to find the point or, 2 points or 3 points or whatever, where the lines intersect. So a system of equations could have multiple solutions or an infinite number of solutions. They could have no solutions or they could have just one solution. So equations with multiple solutions occur when we have two lines that are coincident. So that means that they occur at the same time or that one of them lies on top of the other line. So for example, determine the solution of the following system of equations. Now this first equation, it's already in the slope-intercept form, so we could actually draw that. Now we know that the y-intercept, I'm actually going to get let's get a blue color, and I'm going to start off at positive 3. Now this has a gradient of 2, so that means that for every 2 I go up, I go 1 across. And now I can draw my point or my line through there. Okay, it's just going to be pretty rough. All right, now I'm going to do the same thing, except I'm going to do it with my other solution. Now, the issue with this particular equation is that it's not in slope-intercept form. So we could rearrange it to get it into slope-intercept form, or we could use a different method to graph. So we could use our x and y-intercept method. So since this isn't in slope-intercept form, let's use that intercept method. So just as a refresh, to find the intercepts, we are going to find the x-intercept first, and that is when y is equal to 0. So all we're left with is negative 4x is equal to 6. So x must be equal to 6 over negative 4, which is the same as negative 1.5. Now let's do the same thing with the y-intercept. So the y-intercept is when x is equal to 0. So we're left with 2y is equal to 6. So y is equal to 3. Let's do this in a different color actually, so you can sort of plot the 2 points and we can see them. Now this first point is going through at negative 1.5 and 0, so we can draw a line that's going to be roughly about here. And then this point here is going through at 0, 3, and we can already see that that's going to cross through that point there. So if I now get my equation or get my line up, if I can actually draw it, apparently not. Hold on, I'm just going to go off camera and fix this. Okay, so as you can see, these lines are coincident, and that means that they're going across the same way. All right, so we kind of already knew that though, because if I was to rearrange this equation to get it into slope-intercept form, 2y minus 4x is equal to 6. And so what I'm going to do is I'm going to add 4x to this side, and then I'm going to divide the whole thing through by 2 so that I get y is equal to 2x plus 3. What do we notice about this particular line here versus this first equation here? They're actually the exact same equation. So they're actually the exact same line. So this system of equations has infinite number of solutions because the lines are coincident. All right. Let's move on. Let's talk about equations that do not have a solution. So linear equations can have no solutions if the two lines are parallel. Now, we've talked about parallel and perpendicular lines. We know that parallel lines are something that have the same gradient. So they have to have a different y-intercept. If they have the same y-intercept and the same gradient, then we actually have a coincident line, just like we've just done. But if they have different y-intercepts, it means that the two lines are never going to cross. So explain why the following system of equations has no solution. So how do we know that two lines are parallel? Because they have the same gradient. And these two lines have the same gradient and different y-intercepts, and therefore we know that they're going to be parallel and therefore are going to have no solution. So all I want you to do now is I want you to go through and have a go at question 4 on page 123, chapter 4.2 in your textbooks. And you can do that by chucking that into desmos.com. And if you put it in desmos.com, you should be able to see where the two lines line up without having to manipulate the two equations too much. The other way that you can do it, if you don't know how to get onto Desmos or don't know how to access it, is to just draw it by hand, and then you can see whether or not the two lines are going to have no solution or if they will have a solution. The last way that you can do it is by actually just going through algebraically and determining whether or not there is they have the same gradient or if they have different gradients. All right, so let's talk about equations that only have one solution. So we've actually done these before, and this is actually easier than the stuff that we've done previously, because all you're going to do is you're just going to look at the graph and you're going to go, that seems to be the point of intersection. So what that means is the solution for this system of equations is going to be at 2, 1. And I can check that algebraically. So let's substitute this point into here. If x was equal to 2 and y is equal to 1, 2 plus 1 is 3. So yes, that does work for that equation. Let's do the same thing now. Substitute it into this equation. 2 minus 1 is 1. So yes, it also works for that equation. So yes, 2, 1 is a solution for this particular system of equations. Let's do the same thing over this side. Now I'm going to use my big brain. I'm going to have a look. Oh, what's that there? Is that the point of intersection? It is. So that's going to be at 1 and 1. So let's just double check that by substituting it back into these equations. 1 plus 1 is 2. So yes, it will work for that equation. And 3 lots of 1, which is 3, minus 1 is 2. So it also works for that equation there. Very, very simple. This is where it gets a little bit trickier. So the perpendicular lines, we've talked a little bit about this before. So this shouldn't actually be new information for us. If you do want more information about the perpendicular lines, I suggest going and checking out my video that I have on my channel on perpendicular lines. What we do know is that perpendicular lines meet at right angles and they have negative reciprocal gradients. So this formula here, M1, where M1 is the slope of my first line, is equal to the negative reciprocal of my second gradient line, which is M2. So I want you to determine the gradient of the line perpendicular to y is equal to 3x minus 2. I'm going to get you to pause the video here and I'm going to go through the answer with you. Okay, so this one, again, we've done this before. We know that the gradient of the first line is 3, and so therefore the gradient of the second line is going to be the negative reciprocal of that. So the gradient of the second line is going to be negative 1/3. All right, so what I want you to do now is I want you to go through and practice these questions here. So these first couple of questions are just like what I've done with the graphed solution before. You just find the point of intersection, double check by just substituting into each equation and making sure it does actually work. Very, very easy to do. This is going to get a little bit trickier. So solve each of the following pairs of simultaneous equations using a graphical method. So I want you to graph things either using that slope-intercept form or by using the intercept-intercept method. Again, if you want a bit of a refresher, I do have a previous video on this. And that's it. Easy peasy. I'll talk to you next lesson. Bye, guys.